We're on SAT Practice Test 4, Math, Section 1, Question 22. What's the level of difficulty here? It's hard. Most people are going to find this stupid hard, crazy stupid hard. The good news here is that this question 22 is the only stupid hard question on Section 1. The bad news is that Section 2 on SAT Practice Test 4 has some really bitchin' hard questions. But let's enjoy this hard question before we get to Section 2. The graph of 9x minus 10y equals 19 is translated down 4 units in the xy plane. What's the x-coordinate of the x-intercept of the resulting graph? So what are we looking for? We're really just looking for the x-intercept of the resulting graph. We'll figure out that x-coordinate stuff later. All this problem is about, guys, is y equals mx plus b. And I know that you've done y equals mx plus b. We're going to write down the line that Evil Testing Service gives us. 9x minus 10y equals 19. And we're going to ask ourselves, is this line exactly like y equals mx plus b? And it's not. So we've got to force this line into y equals mx plus b. I'm going to keep the y in the same place because that's where it is here. I'm going to put an equal sign. I'm going to move the x across the equal sign because that's where it is in y equals mx plus b. It changes signs, so it's minus 9x plus 19. I'm almost there. In y equals mx plus b, y has to be naked and alone. We don't have y naked and alone. So we got to divide it by negative 10, which means we have to divide every term by negative 10. And when we do that, we're going to get y, note that it's positive, equals negative 9 divided by negative 10 is 9/10 x. And then it's 19 over negative 10, so it's minus 19 over 10. All right, this line right here in y equals mx plus b form looks like this. If you can get here, you can get this problem right. I'm going to rewrite the equation up here. Translate it down 4 units sounds kind of hairy, but it's not. Think about it. Here's an xy plane. Here's a line. If you're transferring it down, you're just going to move it down. Like that. So there's your new line. You're moving it down how much? 4 units. All right, if you're moving it down, you can move the y-intercept down, and that's going to be the new place of the y-intercept. What's the y-intercept in this line? B is the y-intercept. So it's negative 19 over 10. So negative 19 over 10, if I want to move it down 4, what do I do to it? I subtract 4. You can do this on your calculator. It's probably easier. I'm going to do it the old school bow tie way. Negative 19 times 1 is negative 19. 10 times negative 4 is negative 40. And then I'm going to always multiply the bottoms. So I'm going to get 10 times 1, which is 10. And then negative 19 minus 40 is negative 59. So what's my new line? My new line is y equals, the slope is the same, m is 9/10. X's and y's are infinite on lines, but my y-intercept has changed. What is it? It is now negative 59 over 10, so minus 59 over 10. Okay, what am I looking for? The x-coordinate of the x-intercept of the resulting graph. What is the x-intercept of this graph, of this line? How can I figure that out? I got to make y equal 0. To get the x-intercept, y equals 0. So 0 equals 9/10 x minus 59 over 10. I'm going to do it up here. I'm going to keep 9x over 10 on the right side equals negative 59 over 10. It's going to move across the equal sign, so it's going to change signs. So it's 59 over 10. All right, I'm going to do some excess algebra here. I'm going to cross multiply. 9x times 10 is 90x equals 59 times 10, which is 590. I'm going to divide both sides by 90. I'm going to get x equals, those zeros go away, and at last, after all that work, it's 59 over 9, And that's it. That is the x-coordinate of the x-intercept. It's a hard problem. It takes a bunch of steps, but all it's about is y equals mx plus b. Get it right and move on to section 2.